Question number 91 on page 115 gives us S of t is equal to negative 16 t squared plus v sub 0 t plus s sub 0. And then question 91 tells us that a silver dollar is dropped from a height of 1,362 feet. And we are asked several things. So S of t, that means position, equals negative 16 times time squared. V sub 0 is velocity at time 0, so the initial velocity. S sub 0 would be position at time 0, initial position. So part A wants us to write functions for position and velocity. So we need to write an equation for position. So position is equal to negative 16 t squared. If the silver dollar is dropped, that means that it had an initial velocity of 0, so that would be plus 0t, plus its initial position, and if it was dropped from 1,362 feet, that is its initial position. So there is the position function. To get the velocity function, velocity is the derivative of position. It's the rate of change of position. So I just need to take the derivative of this. So 2t times negative 16, that's negative 32t, and the derivative of any constant is 0. So there's part A. Part B asks us to find the average velocity from 1 to 2. So average velocity. To get average velocity, we are going to get two positions and find the slope, find the rate of change between those two positions. So our interval is from 1 to 2. Whoops. So we're going to get the position at 1 second, the position at 2 seconds, and find the slope in between those two things. So plugging 1 in for time into position gives me 1,346 feet. Plugging 2 into position gives me 1,298 feet. So the slope between those that's a divided by symbol. Gives me negative 48. This is a velocity. Notice I took a position and divided by time. That is a velocity. So I should get negative 48. Velocity would be measured in feet per unit time, which is per second. Part C. Part C wants the instantaneous velocities when t equals 2 or 1 and t equals 2. We have an equation for velocity right here. So it wants to know not the average velocity, but what are the velocities at 1 second and 2 seconds. So we just need to plug velocity in to v of t. So plug in 1, gives me negative 32, and plug in 2, gives me negative 64. Part D, find the time required for the coin to reach ground level. So when the ball is at ground level, or the silver dollar is at ground level, its position is 0. It has reached a height of 0. So we're going to plug in 0 for position, and we're going to solve for time. Divide both sides by 16. And take the square root. And I get t equals, remember we always round to 3 decimal places, 3.2 or 9.226. Time in this problem is measured in seconds. And part E, find the velocity of the coin at impact. we have an equation again right here for velocity. So all we need to do is take the amount of time it took to get to the ground and plug that into velocity. So the velocity at 9.226 seconds is, and I would plug in the big long decimal, not the rounded decimal here. Just you have that on your calculator as the last thing you entered. Just push times negative 32. So the velocity is negative, which tells us it's moving down at 295.242 feet per second. Whoops.